question 236, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of lowest common ancestor, is defined between two nodes P and Q as the lowest node in the tree that has both P and Q as descendants. And also we should know that we allow a node to be a descendant of itself. So let's see this example. In this example, we want to find the lowest common ancestor of node 5 and node 1. The lowest common ancestor that they have is node 3. That's the node that they have in common, right? And we know that each of these can be a descendant of itself, right? So this is a descendant of itself, this is a descendant itself, but the lowest common ancestor that they have is 3. In this example, we are going to find the lowest common ancestor for node 5 and node 4, right? So node 4 is descendant of itself, and the lowest common ancestor is 2, but it's not common with 5. So now let's see, 5 is the lowest common ancestor of itself, and the lowest common ancestor, the second lowest common ancestor is 3. So 3 is common between these two, but 5 is lowest common ancestor for 2 and itself. So that's why we are going to return 5 as the lowest common ancestor. And in this one, we have 1 and 2, and we want to get the lowest common ancestor. So we are going to return 1 because 1 is the lowest ancestor of 2 after itself, and 1 is the ancestor of itself. So let's see how we can code this question. So what we know is if we don't have if we don't have root, if not root, or if the root that we have is equal to Q, or if the root that we have is equal to P. So any of these cases, if we don't have a root, or if the root that we have is equal to Q or it's equal to P, we are going to return root as the result, as the lowest common ancestor. This is the base case that we have. We are going to use recursive. The way that we do it is like we start from the root, and then we get the left and right child, and for each child we get the left and right child, we get the left and right child, and for each child we keep doing that until we hit the null for each node. And the base case that we are going to have is we are going to say, if we don't have a root, or if the root that we have is either equal to Q or P, we are going to return root as the lowest common ancestor, right? And after this, what we need to do, we need to find the left and right nodes. So let's say left is going to be equal to lowest common ancestor. We are going to call this function recursively, and for the root, this time we are going to say root dot left. The P and Q are the thing that we are going to have constantly in the program, so we are not going to change that for this PQ. And we are going to get the right, and this time it's going to be for the lowest common ancestor. This time it's going to be for the right child, root dot right, and P and Q are the same, right? So now we are going to call this function recursively. Then what will happen? Then we are going to say if left and right, we are going to return root. And if just left, we return left. And if just right, we return right. Let's run this code and see how it works perfectly. So it works perfectly. I'm going to tell you something. I got this solution from this profile, the Stefan profile. Like, he has many good solutions. When you check the discussion, you can find them. And one thing that I want to say here, when we write if left and right return root, the meaning is like we can get either for left and right none or a value, right? It's either the null node, so there is no leaf node, or there is a value. So if you can see here, if I get the and between a digit and none, I get none. And if I do and between none and none, I get none. So when I have a condition and I say none and none, print yes, it doesn't do anything. So none is not true or false. None is like something for itself, but some we can say it's like false. So when we say none and none, prints if none and none, it doesn't do anything. And even when we say none and one, it doesn't do anything. But when we have two digits, it returns something. So it's the same thing here. When we have none and none, it doesn't do anything. So it checks if we have left or if we have right? And for example, I have wrote down the one that we are doing here. So the root is 3. The number that we are looking for, let's say it's 5 and 2. Okay, let's run this. Okay, it's going to return 5 as the lowest common ancestor. So we have root is 3, P is 5, Q is 2. So Q and P are going to be the same all the way down. But let's go through this. So we go to the right, it's going to be 5 and 5, 2, and it's going to be 1 and 5, 2. And then for 5, it says if not root, or root is equal to Q or P, return root. So 5 is equal to 5, we are going to return 5. And for this one, because 1 is not none or is not equal to 5 or 2, we are going to check the left and right side. So we get 0, 5, 2 and 8, 5, 2. And again, the same thing, so we get the left and right. So it's going to be none 5, 2 and none 5, 2 and so on. So when we have none, so it's going to be the left side is going to be for the left side, it's going to be if left and left return. So left is none, this is going to be none, and this is going to be none, right? So if it says if not root, return root. So not root is going to be none, so we are going to return none for these two, and we are going to return none for these two, and we are going to say none and none is going to be none. So the output of the whole like right side is going to be none, right? So that's why we return 5 as the result.